Hello everyone, welcome to lesson 5-10, Indirect Measurement. This lesson is found on page 238. What do we mean by indirect measurement? Well, with indirect measurement, we're going to use one measurement to find another one, okay, indirectly. So the measurement is not given to us directly, it's indirect, but we will solve it by using other measurements, okay, in proportionality. So what are we going to learn? We're going to solve problems involving indirect measurement using shadows reckoning. Solve problems using surveying methods. Surveying, like studying or making an observation, physical observation. So when we talk about shadows, let's think about this. Have you ever looked down and found that your shadow and the shadow of a person next to you were different lengths? This is because the length of your shadow is proportional to your height. So unless you and the person next to you are the exact same height, your shadows will be different lengths. And your shadow also depends on not only your height, but also the positioning of the light of the sun. If the sun is low, you know that you're going to block the sunlight a lot more, so that your shadow will go even further out. So your shadow will be about this long. But if, let's say, the sun were up here and it was shining down this way, your shadow would be short, because that's only it all depends on how much you're blocking the light, right? So bringing it back to geometry, you can see that we have a statue here, and we go right from the foot of the statue directly to its highest point, and then we go 90 degrees out. And we can measure, okay? We can measure, let's say we know how long the shadow is. It would be easy for us to measure. It might not be easy for us to measure the statue because it could be too tall for us to do it, but we could measure the shadow, and we know the length of our shadow, and we know our height. So by knowing this, we can proportionally solve for h. We see the difference from this to this, from this shadow to this shadow. We see the difference. So we do the same from this to this, as we've been doing with cross product. So the lead statue of Korean War Memorial in Washington, D.C. cast a 43.5-inch shadow. At the same time, a nearby tourist cast a shadow of 32 inches. If the tourist is 64 inches tall, how tall is the statue? So that's what we were just looking at right there, okay? Now, the math is exactly as we've been doing before. We need to identify the ratios. So we know that in one side it's 64, while on the other side it's 32. And one shadow is 43.5. Well, here's the height that we don't know. So we have to figure out that h. We can do cross product, 64 times 43.5, as you see there, and 32 times h, as you see there. And then we isolate the h over here, so we divide this side by 32. So we bring the 32 over, as we've done in the past. We isolate the variable right there and invert the operation, so that this becomes divided by 32, and we get 87. So the statue is 87 inches tall. So now let's try the word problem. Suppose a bell tower, this is my sad attempt at drawing a bell tower, okay, casts a 27.6 foot shadow, 27.6 foot shadow. So we'll call this the shadow. So here's our tower, and here's our shadow. At the same time, a nearby tourist casts a 1.2 foot shadow, 1.2 shadow. There's our tourist, 1.2 shadow. If the tourist is 6 feet tall, you see there's our tourist, he's 6 feet tall. How tall is the tower? So we know that 1.2 feet on this side is going to equal 27.6 feet. Okay? Well, it's similar. We shouldn't say equal, right? We should say similar, but we're going to work proportionally, so it will be equal. And we know that 6 feet, okay, so that's a 6 foot shadow, 6 foot tall person with a 1.2 foot shadow. 6 foot tall, 1.2 foot shadow. Here's my shadow, and I just don't know the height of the tower, so that's going to be represented with our variable x. Now we know the process. We can cross multiply, okay, and then divide. So it looks something like this. 6 times 27.6 is equal to 1.2 times x. Now I want to isolate my variable, so I will bring this 1.2 over to this side and divide 165.6 divided by 1.2. And that's going to equal 138, and that's what my x is. X equals 138. Therefore, the bell tower is 138 feet tall. Forgot my therefore symbol. Please copy that down. So on the next page, we're going to talk about surveying methods. Now, when we talk about surveying, a surveyor is somebody who studies the land, okay, and they determine what's going to be built on the land. So they survey the land, they study it, surveyor. So surveyors also use similar triangles, like we did here. We used the triangle method to identify the height of the statue, right? But they use similar triangles, except they use them invertedly and so on. But their method does not involve shadows. Notice in example 2, this is example 2 here, that it is possible to measure 3 sides of the triangles directly. Okay. So here, what we're using is, we want to identify the width, the widest part right here of this pond, right? And what we're going to do is they solve by creating a different triangle, and we understand that this triangle right here is, and with this exact line measuring with 90-degree angles, okay, opposing 90-degree angles, and then we put a straight line that goes all the way across it, okay? And we are able to identify that the height here is 10 meters, the width is 20 meters, while the height of this same triangle upside down, the similar figure, is 16 meters, and we still don't know what this is. So what we're going to do is, let's identify, you know that this side is similar to this side, right? We're going to identify the proportionality. How much did we go up by from 10 to 16? Well, from 10 to 16, we went up 60% of 10, right? 60% of 10 is 6. So we went up by 60% of the first number. Did we not? So what is 60% of 20? Well, 60% of 20 is 12. It's double this, right? So double 6 is going to be 12. So it's 12. So we have to go up by 12 from 20, and that's going to give us our 32. Let's see if that's true. In the figure or triangle STU is similar to triangle VQU. You see that here. So we write out our ratios where we say UQ and UT will move up proportionally. UQ is right here, okay? UQ and UT, okay, that's the ratio there. We'll move up proportionally with VQ, VQ right there, and ST. They will move up proportionally. We replace the variables. We do our cross products. Then we multiply. We isolate the variable, or take away 10 from both sides by isolating the variable, and we get 32. As we did, just by eyeing it out. Okay, now it's our turn. We're going to look in the figure triangle QRS. QRS. It's similar to triangle URT. URT. Now let's see here. Okay, we have 46. Okay, with the 90-degree angle, 46 is matching, or it's going proportionally up to 138. So that means that 60 yards, our line that is on an angle, 60 yards is going to match X. Now, boys and girls, let's eye it out. See, this is a talent I want you to develop. What did I do to the 46 to make it 138? I think some of you can already see that 46 times 3 equals 138. Or you can say 40 times 3 is 120, and 6 times 3 is 18. 120 plus 18 is 138. So we tripled it. So that means we must triple this to get this, to move proportionally up. So 60 times 3 is 180. So X equals 180. So let's write it out. QR, right there, is going to be proportional to RU. And SR, right there, is going to be proportional to RT, right there. So now we replace our variables, and we get X over 138 equals 60 over 46. Okay, these are our ratios. What did I do to the 46? Well, let's do our cross product. Okay, cross product. So I have 60 times 138 and 46x. After multiplying 16 times 138, I get 8,280 equals 46x. Let's isolate the variable and divide this side by 46. So that we get now, remember the 46 is no longer there because we brought it over to this side and we inverted the operation. So when we divide by 46, we get 180 equals x. And that's just what we mentioned earlier. Okay, go ahead and try the guided practice on your own by doing the same exact thing that we did. You have only two questions, example 1 and example 2. And go ahead and try it on your own. And this is the only practice you have to do today, because we will do the independent practice in class. Here's the entire independent practice. Okay, if you want to go ahead and take a look at it before time, you can feel free to do so. See you in class.